Okay, I'm back, ladies and gentlemen, and talking more about safety due to grounding. The way things are done, this is the handle. This part is the case that you hold of a drill or some other electrical appliance, and you have the power and all the motors and all that stuff and a switch in here, and this is the case. This is when you cut off the third wire. That you don't do that. So now, if for some reason there is a short, and it happens, if there's something wiggles, something mechanical gets loose, a piece of metal falls, so you have a connection between here and here. Guess where and this switch is closed. Of course, the device is operating. So you'll get current going through you, down and going away. And remember, you're cooking, you're getting cooked when this happens. Not good. Not good. So that's why never cut off the third prong. Now, I've noticed sometimes that a transformer, it's plastic. You don't have any metal on the outside of a transformer like a computer, and it's plastic, so there's no way you can get shocked, and it's got a third wire on it. And I was curious about that, said, why do you need that third wire for that transformer? What's going on is you have the power to your computer, power. It goes to the transformer. There's a third wire, there's a ground wire. It is connected to computer ground. So here's your computer. You've got a second transformer, a step down transformer, your computer. And its power runs out this way. Now, what happens is you get signals coming out of the computer, and there's a ground. Those signals have a ground. And let's say you're trying to go to a projector. Well, a projector has the same situation. It's got the power going to it and the return power and a ground. The reason for the third wire, third connection, is so that this ground wire here is connected to here, so that this ground wire, which is the white wire, the return wire, white, that goes to the projector, and the signal wire goes to the projector. The potential here, 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 it's all the same. If you cut this, if you cut the third wire, and let's see, yeah, ground and third wire, ground here and all that stuff. Anyway, if you cut the third wire, you will you have resistance in this area here, in this area here, this area here, that by making an earth ground, the projector is at the same potential, the ground wire, the projector is at the same potential as the ground wire of the computer, which is at the same potential as the ground wire of the transformer. You get spurious signals if you don't do that. If you have a break anywhere in here, you can get spurious signals, and the projector looks really weird. The computer doesn't display properly. So it's not a safety issue as much as a signals issue, to keep weird signals off of your lines, that we have a third wire on computers and transformers and the like. Okay. It's not only about safety. Okay, let's go to the next topic. Okay. Ground fault interrupters. GFIDs, ground fault interrupt detect, that if this is in bathrooms and the like, if there's somehow a connection between here and here, you're not going to get any current through here. This will be unbalanced, and you'll have a signal coming out of here. Normally you have one current going this way, another current going this way, and the magnetic fluxes are equal and opposite, so you don't have any signal coming out. But as soon as this goes to zero, you'll have a voltage coming out of the sensing coil, and it'll trip the circuit. It's a protection device. Ground fault interrupt. Okay. This is another example. If your ground prong is removed, you are, this is the ground. The ground prong is removed. The ground is the green wire. If it's removed, you are the current conduction path to ground. This gives some values of typical resistances of your body. Okay, it can be bad for you. It can be bad for you. Another trick is always leave the left hand in your pocket when you're working on electrical stuff, because if you grab a hot wire with your right, the current flows down the right side of your body, and your heart is on the left side. So unless your heart is on the right side of your body, leave your left, work with your right hand only if you suspect there's a hot wire, and double check to turn everything off before you work on it. But things happen. Frankly, I went to Mexico, and they had some poor electrical wiring, and it can happen. Okay, so just using this little example, we can see the current going through you can be pretty significant, and it can cause your heart to stop. That's the biggie. It won't cook you. It's not enough to cook you, but it can cause your heart to stop, which is pretty bad. Here's a scenario, like in a bathtub, a hot tub, things like that. So if you don't have it grounded properly and you get electricity in the water, okay, you're on a vinyl insulator in the water, no problem. But as soon as you go to step out, as soon as you make that connection, as soon as this hand reaches down to the metal bar, boom, you're in trouble. And again, this models what happens if you don't have the third wire. You really need that third wire. As protection, similar situation here. You want the only return path to be here, but if you have a short of some sort, it can go, right from your shoulder right through your heart to your leg. One thing though, they have it on their right leg. You'll notice the heart is on the left side. So this is sensing, by the way. These two wires are just sensors. But an accidental current could go through your heart. more, it's a little bit away from your heart since it's going down the right side. If this electrode was on the left side, it would go straight down through your heart, which you don't want. Accidental grounding. Okay. Here's another thing that could happen. Somebody's working near electrical lines, have a big fat voltage. They're insulated in the cab. 7200 volts going to ground. And the trouble is, as soon as this person walks out, they're going to get shocked. So, the crane, yeah, so this has to do with earth resistance. There's essentially a resistor right here. A lot of voltage, a lot of current too. So you have rubber tires, you're insulated while you're in here, or you're in a Faraday cage, you're surrounded by metal, you're fine. But as soon as you step out into the ground, it's like the boy in the hot tub. Let's go back. There, it's like this guy. As soon as he steps out, he's in trouble. Okay, same thing with the car. Same idea. You're in the car, you step out, a power line falls on it, you step out and zap. Very dangerous. You want to get the power line off the car before you do anything. Okay, that's it. Last video for this chapter, and we'll move on to the next chapter, which is, I can't remember the number, but we're skipping a couple. We're skipping some magnetics stuff. Transformers have to do with magnetics. So, see you at the next video.